practicing medicine without being able to see inside the body, performing surgery without knowing beforehand which bone was broken, or trying to diagnose a condition based solely on the patient's outward symptoms. The ability to see inside a living human body without cutting it open was a turning point in the history of medicine. In the late 1800s, Dr. Wilhelm Conrad Röntgen, a German scientist and mathematician, studied at the Polytechnic Institute in Zurich. He was appointed to the faculty of the University of Würzburg and was the director of the Physical Institute at the time of his discovery. As a teacher and researcher, his academic interest was the conduction of high-voltage electricity through low vacuum tubes. A low vacuum tube is simply a glass tube that has had some of the air evacuated from it. The specific type of tube that Röntgen was working with was called a Crookes tube. Upon ending his workday on November 8, 1895, Röntgen prepared his research apparatus for the next experimental session to be conducted when he would return to his workplace. He darkened his laboratory to observe the electrical glow, the cathode rays, that occurred when the tube was energized. The glow from the tube would indicate that the tube was receiving electricity and was ready for the next experiment. On this day, Röntgen covered his tube with black cardboard and again electrified the tube. By chance, he noticed a faint glow coming from some material located several feet away from his electrified tube. The source was a piece of paper coated with barium platinocyanide. Not believing that the cathode rays could reach that far from the tube, Röntgen repeated the experiment. Each time Röntgen energized his tube, he observed this glow coming from the barium platinocyanide coated paper. He understood that energy emanating from his tube was causing this paper to produce light, or to fluoresce. Fluorescence refers to the instantaneous production of light resulting from the interaction of some type of energy, in this case X-rays, and some element or compound, in this case barium platinocyanide. Here is a demonstration of the principle of fluorescence. When a certain material is exposed to radiation, it gives off light. When the radiation stops, so does the glowing light. This is how Röntgen first noticed there was a different type of radiation being produced from the Crookes tube. Röntgen was understandably excited about this apparent discovery, but he was also cautious not to make any early assumptions about what he had observed. Before sharing information about his discovery with colleagues, Röntgen spent some time meticulously investigating the properties of this new type of energy. Knowing that others were doing similar research, Röntgen worked in earnest to determine just what this energy was. Röntgen spent the next several weeks working feverishly in his laboratory to investigate as many properties of this energy as he could. He noticed that when he placed his hand between the energized tube and the barium platinocyanide coated paper, he could see the bones of his hand glowing on the paper, with this fluoroscopic image moving as he moved his hand. Curious about this, he called to his wife Bertha and said, "Let me show you what I'm doing, because no one is going to believe this." Then he placed his wife's hand under the tube and produced a static image of her hand using a 15-minute exposure. Upon seeing the image of the bones in her hand, she is reputed to have said, "I have seen my own death." In those days, people only saw a skeleton after someone had died. The idea of seeing part of the body on an image of a living person was beyond anyone's imagination. This became the world's first radiograph. In December 1895, after much study, Röntgen decided that his investigations of this energy were complete enough to inform his physicist colleagues of what they now believed to be the discovery of a new form of energy. He called this energy X-rays, with X representing the mathematical symbol of the unknown. On December 28, 1895, Röntgen submitted a scholarly paper on his research activities to his local professional society, the Würzburg Physio-Medical Society. Written in his native German, his article was titled "On a New Kind of Rays," and it caused a buzz of excitement in the medical and scientific communities. Within a short time, an English translation of this article appeared in the journal Nature, dated January 23, 1896. Röntgen views his discovery as an important one, but he also viewed it as one of primarily academic interest. His interest was in the X-ray itself as a form of energy, not in the possible practical uses of it. Others quickly began assembling their own X-ray producing devices and exposed inanimate objects as well as tissue, both human and animal, both living and dead, to determine the range of the use of these X-rays. Their efforts were largely driven by skepticism, not belief that X-rays could do what had been claimed. Skepticism eventually gave way to the productive curiosity as investigations concentrated on ways of imaging the living human body for medical benefit. Röntgen's discovery was lauded as one of great significance to science and medicine. For his efforts and discoveries, in 1901, Röntgen received the first Nobel Prize presented for physics. The branch of medicine that was concerned with using X-rays was called Röntgenology. A unit of radiation exposure was called the Röntgen, and X-rays were, in the early days, often referred to as Röntgen rays. Within a few weeks, the world had changed. The legacy left by Röntgen can be found throughout medicine, in plain film X-rays and complex CT scans, and all the way to NASA's Chandra telescope, which astronomers are using to observe and record X-rays from across the universe. All from a discovery which happened by accident.